Awesome. All right. Hey, everybody. We're going to be live here in just a moment. If you're coming in now, that is awesome. Welcome, everyone, to the chat. Hello, hello. Hey, Palash. Welcome in. Hey, Raghav. Welcome. GM Jam, what's up, creator? I'm glad this is working. All right. We're going to get started in about 2 or 3 minutes. We're just going to let everyone roll in. We have a bunch of people coming from Discord as well. Oh, Prince. Wow, Prince, it's so good to see you. How you doing, Prince? Been a while. Hey there, Arun. Oh, that's you, Prince. Same person. Very hyped about CDR in healthcare. Awesome. Yeah, that's actually one of the main use cases for today. So we're definitely going to be talking about that. All right, we'll wait a couple more minutes to see. We have about 36 people in here, which is amazing. Welcome, everybody. We're going to get started with the opening ceremony in just a couple minutes. We're just waiting for all of our friends to tune in since we just went live a couple minutes ago. Thanks for joining in. If this is early morning for you or late at night, great to have you. We tried to make this successful for people all around the world to tune in. So it's great to have everyone here. Someone said Jacob will have an opening dance. Well, we'll see about that. What could the opening dance be? Here, you want an opening dance? What's like? You guys remember Orange Justice from Fortnite? That'll be every time HumanBot comes into the chat, it's always a problem. Crump dance? Oh, true. I actually kind of know how to crump now because I've watched your videos. Oh, the baby shark. Actually, no, it's this, right? Or something like that. I can't really remember. All right, cool. We got this officially loading here now, which is great. All right. Awesome. So it looks like we have about... Oh, hey, awesome. Great to have you, Tenor. I hope I'm pronouncing that right. Welcome in. Thanks for joining. We're live on both. Obviously, if you're tuning into this, you're probably tuning in on the live page, which you can get to by going down to the schedule and clicking on the live link here. So you're probably live here. Or you can also go to our Twitter and view it live on our Story Engineers Twitter. I think this might be glitching, but either way, it doesn't really matter. I see there's a bunch of people here on our engineering Twitter, which is great, and also here. So, yeah, it's awesome to have all you guys. Okay, so if at any point the live stream stops working on this website, you can always go to our Story Engineering Twitter. So definitely check that out. If if for some reason it stops working, but yeah, again, welcome everyone. My name is Jacob Tucker. I'm on the Story team. I'm actually the head of DevRel here at Story. And we're really excited to kick off with the CDR Hackathon. So CDR is short for Confidential Data Rails. And it's the latest update to our protocol that we're really excited about. It's currently live on our testnet. You're going to get a whole introduction to what CDR actually is by Ramtin, the co-author of CDR, who's also here. Is just sitting off stage right now. I'm going to give a brief introduction to CDR, what this hackathon is all about, why we're hosting it, and kind of why all of you are here. So, like I said, CDR was launched on Story only a couple weeks ago, actually, on testnet, we are having this hackathon for a few reasons. One, because we're really excited about the new tech, and we think it's going to unlock a lot of new use cases. But B, because we also want to gather feedback around CDR before we actually launch on mainnet and have all of you build awesome applications with it, in production-ready apps, right? So if I think a lot of you actually here are already kind of familiar with what Story is, but Story is a L1 blockchain. We've been focused on creative IP and more importantly data in the most recent weeks. Where you've probably seen we launched the Numo app. Numo is an app where it's a data collection app where you complete tasks and then that gets registered as IP on Story and you get paid out for completing those tasks. But in the current world, right, there's a lot of data, right? There's data collection, there's registering data, there's getting paid for your data, getting paid for your time. This is all, if you think about it, sensitive data, right? And there's all types of sensitive data. There's data you contribute, like I was talking about. There's healthcare data, like Prince was talking about here in the chat. There's biomedical data. For those of you that follow the biomedical space, there's been really awesome improvements in peptides recently. I've actually been kind of excited by peptides myself. This is all sensitive data, right? And the way that sensitive data is currently shared and bought and licensed on the internet is very, I guess you could call it ancient. It's very ancient. There do exist, for example, like data marketplaces where, users, let's say, publish their data for sale. But the moment that data is sold, right, the user loses control. The user loses control of their data. They're paid a one-time payment, if that, and then the data is kind of out there and it's public. And once the data is public, the owner loses control. And so CDR is a way of giving control back to data owners, allowing data owners to set programmable access conditions around their data, right? So whatever you can code into a smart contract, you can gate via CDR. So you can have your data, for example, only available to one person, or only available after 7 days, or only available when someone mints a license to your data, or only available, to, for example, people that purchase your data, right? So it's a way of gating, and this is the most important part. This is the crux of CDR. It's a way of gating private data via programmable access conditions. Okay, and so that's going to be the whole crux of this hackathon. So if I'm sure you've already all checked out build.ucdr.dev. If you for some reason somehow you haven't and you're tuning in via Twitter, I just posted in the chat. And if you haven't yet signed up, please do so by clicking on the sign up on Luma link here, just so that we can kind of keep track of your sign up submission. And also, if it's helpful, there also is a subscribe to calendar button where we're having, it's just a Google Calendar for you to keep track of all your workshops. That it's this one, the Korean Builder Workshop tomorrow, and then the English Builder Workshop tomorrow that I'm going to be hosting. So you can make sure that you're up to date by subscribing to that calendar. So We kind of already walked through what CDR is. I'm going to kind of skip over this just because I personally hate long opening ceremonies. I don't want to bore any of you. So I'm going to get through this as quickly as I can. And then we're going to hear from Ramtin on what CDR, really is. And he's going to do a much better job than me. So we have a bunch of, starter examples or ideas here. A bunch of you have already been reaching out to me asking about, ideas to build, and a bunch of you already have really cool ideas. But if you don't, you can kind of look here. We have a simple on-chain private storage, right? CDR is a way to gate private data. So this is kind of a simple, a simple idea. A data marketplace, like I talked about, agent-to-agent deals, which I'll talk about in a second, and a bunch of other crazy ideas. But you're always welcome to, talk to me in Discord, on Twitter, DM me, tell me about your idea. I'm actually going to be judging every single project. So there's really no better way to make sure your project is good than to reach out to me, because I can validate your idea and help you win, right? I want to help you win. So there are 2 example app ideas that I provided here to kind of get the gears spinning. One of them is more on the application side, and one of them is more on the AI agent side. There's a lot of different ways you can approach this. So I'm going to show you a brief demo of both of these, so you can kind of get an idea of what CDR is before you hear from Ramtin on, a more a better explanation, right? So Scroll is an app that I made that allows you to. This is actually, you can see it on my screen now. It's an app that I built that allows authors to publish mini blog posts. Okay. So you can see here, I can load up my account. I can click on new Scroll here, and you can actually try this yourself if you go to onscroll.app. This is a example blog that I generated. But in this blog, let's say, for example, that I wanted to gate a piece of this content. I can scroll down and say, for example, we'll get rid of this one so I can read you the example. But let's say there's a map, right? And I'm writing about, following a map. In here, I can gate this content. I can lock it. I can call it a title, secret map, and put a description or whatever. And I can say, I want to set the price to $5. So in order to unlock my map, you have to pay $5. And I'm going to say, okay, this is going to be a file, and I can upload a file here or text, right? So it's either one. I could put the map file or a piece of text, and I could say the hidden treasure is at, and then put the coordinates, right? And if I say this unlockable, all of a sudden, when I eventually go to publish this article, readers can unlock this map by paying the $5. And what that's going to do is it's going to actually pay the $5, mint the license on Story, and then allow me to decrypt the data via CDR. So this is one sort of visual example of CDR, right? In a quite basic scenario, right, where I'm just encrypting and decrypting secrets in a blog post. And this can be used for all different sorts of ideas. It can be used for secrets. It can be used for gossip. For example, a really popular example is, Brad Pitt was seen in the middle of Italy having an affair. Who was it, right? And then you can kind of gate the name or pictures of the affair, for example, behind CDR. Or it could be a multitude of other things. It could be an educational tutorial where in order to unlock the next chapter, you have to pay, right? Or, for example, I have this amazing AI agent prompt that you can only get by unlocking this piece of content. So that's the Scroll example. And again, just sort of getting you thinking about how can I make an application around CDR? And then the second example is AI Negotiate, which is more of just like a visual demo. However, there's a full GitHub repo. If you go to the landing page, you can click on View on GitHub, and there's a full back and forth demo between 2 AI agents negotiating on data. So in this example, imagine there's a research agent that wants to get more research because he wants to train himself. And then there's a CDR data owner. This is an agent that, for example, just has data that the research agent wants to purchase. And so in this example, we're actually using quite a few things just to, kind of make a cool submission here. We're using Google's A2A and Google's AP2 standard, which are basically standards for how AI agents talk to each other. So it's Google's standard. And then what we're doing is we're using CDR to encrypt the data. So in this example, a research agent uses Google's A2A to discover this data owner agent. And the research agent opens a negotiation. It says, okay, I really want your data. I want to purchase it for 0.87 IP, right? And then the data owner agent says, actually, let's do it for a different price, right? In this case, this is kind of a funny example because he proposed less, but actually, yeah. So they agree on like 0.61 IP. Then they agree on the price. The research agent signs via a Google AP2 standard saying, okay, I'm gonna purchase that. They finalize the deal. And what happens is the research agent mints a license to the data owner's data. And once it does that, it's able to decrypt the data, okay? And so this is sort of like a visual example, but you can actually run the full back and forth AI agent negotiation on the GitHub repo locally if you want to. So definitely check that out. All right, so those are two examples just to get you thinking. Again, if you have any more ideas or you want to run them by me, just let me know in Discord. There's two main tracks. The first track is for technical implementation. So this is for projects that really dive into, for example, smart contracts or using the SDK in ways that are unique. For example, the basic overview of CDR is that, in order to encrypt or decrypt a secret, you can set a read or write condition. So who can read this data and who can write this data? This is all set in smart contracts. And so you can write really complicated, read conditions, for example. Like you can only unlock this data if you borrow blah, blah, blah in some DeFi application, or if you do some really complicated thing in the smart contract. That's what we're kind of looking for in the technical implementation. So using the CDR protocol in ways that are unique and difficult. And then there's the best CDR application track, which has two winners. Both are equal. So if you get first or second, you're going to get the same prize. It's kind of, at this point, if you get first, it's kind of just like you get to brag about it, right? So you get to tell the runner-up that they're an idiot. So this is for best CDR applications. So this is for applications that do a couple of things. One, of course, they use CDR. Two, they actually create an application that looks beautiful, that looks nice. In the age of AI, right, we actually are able to make really beautiful interfaces. And so we're actually looking for applications that are deployed, that use CDR, and that are actually, like, in a way, except for using real CDR, real money, are production ready in the sense that they look nice. They understand what it means to have good user experience. They understand what it means to have decent design, right? Not everyone is a designer, but at least to have the design sense, and to just create polished applications, okay? So those are things I'm going to be looking for. Does this use CDR? Is this a good idea? Would this make sense in the real world? Would someone actually use this? And does it look nice, right? Does it look like I could actually use it? So those are the two tracks. Then this is the schedule, obviously. So we have the opening ceremony and what is CDR workshop now. Tomorrow at 7 a.m. Eastern or 8 p.m. In Korea Standard Time, we're going to have someone from our team. I believe it's either Jongwon Park or maybe someone else joining him. They're going to give a workshop on building with CDR in native Korean language. And then at 11 a.m. Eastern tomorrow, I'm going to give a workshop on building with CDR in English. So that way, hopefully that at least covers those two bases. And if you have any further questions, you can let me know in Discord. So projects are due 1 week from today. Okay, so next Wednesday at the end of the day. Okay, so you're going to have all of next Wednesday to work. As long as you submit it by your local midnight time, that's okay with me. And then I'm going to judge all of the projects on next Thursday. And then next Friday, we're going to have demo day. So I'm going to select the winners. I'm going to let the winners know that you won. And then you're going to present live, right here with me and get to show people what you built, which is really exciting. Okay. So all you have to make sure you do is sign up. If you already signed up, you're great. Join the Discord by clicking this link. Tune into the workshops if it's helpful. They're not mandatory. And then, I will instruct all of you on how to submit your projects next week. So don't worry. There's no live submission link yet. If somehow you finish your project this week and you don't want to work on it anymore, just wait until next week to submit because we'll have that ready next week. Lastly, there's all these resources available for you. There's the CDR SDK docs. So if you want to just point your agent to it, you can do that. We also have the CDR agent skill. So if you go to my GitHub repo and simply click on skills, actually, if you just kind of scroll down, you'll see there's a command to install this directly into your repository. This is very helpful. People have actually said that when they installed the CDR skill, the agent kind of figured out how to build a CDR right away, which is great. And of course, all you should be building with AI. It's definitely helpful. So you can use that. We also have app examples, the CDR white paper, the launch blog, and of course, the Story Builder Discord to answer any questions. So before I hand it off to Ramtin, does anyone in the chat here have any questions about building with CDR or the hackathon? Or are we all feeling good? Oh, I see Prince posted for the vibe coders. Ooh, nice. Thank you. Basically, nice. They're including all the links you can point your agent to. Nice. I like that. Yeah, when I build on CDR, I find it helpful just to like literally paste, the SDK docs and the examples right here. The tracks, sure, I'll go over the tracks really quickly. So there's 2 tracks. One is the technical implementation. This is for the projects that use CDR at a technical level, the best or the most unique. They write the most advanced write conditions, read conditions, etc. And the best CDR application track is for projects that build the best rounded application, the best idea, the best design, it looks the best, and also an app that will be used in the real world, right? An idea that is actually well thought through. And if you have any further questions on tracks, you can let me know in the Discord after. All right. Awesome. Sounds like we're doing great. So I'm going to hand it off to Ramtin here to talk about what CDR is. And if you all can, please give him a round of applause in the chat as he begins his presentation. So yeah, let me add Ramtin onto the stage here.
Okay.
All right.
Thanks, Jacob. Yeah, very excited, even more after you presented CDR. So
Woo!
I'm very happy to talk about CDR, and this is a project we have been working on for some time, and I'm really happy that it's finally on testnet and it's accessible by developers. And it's really exciting because we started with like very specific problems in mind. We definitely wanted to build a very specific application, but let me first share my screen and this is the one. Okay. There we go. Okay. I'm going to talk about CDR, but I'm around. So if you have any questions or anything, you can always reach out to me or Jacob to ask. Okay, what was the problem? Let's start talking about the problems. So we started designing CDR with this specific problem in mind. So we wanted to develop a decentralized and a scalable protocol for async data exchange between multiple parties. So I highlighted a couple of things here because it was very important to us. The first one, we wanted to be decentralized because we believe in that, right? We wanted to be scalable. We didn't want something that is like a proof of concept that's not going to scale well. We wanted to be asynchronous because these parties, we assume, is over the internet, and synchronized communication is less likely these days to happen when you have parties or agents or users that spread around the world, and they want to do this. And the data exchange was the centerpiece of this. So this was the problem we were trying to solve. And first we'll start like looking around, see like what we can do about this problem, let's assume. And this is a very generic like definition of this problem, because based on different applications, it can have different meaning. So you can have like, consider the data can be any format, any size. It can be an API call, it can be training data, it can be agent interaction, it can be any exchange of data that has to happen, private data that has to happen. Can we do it in a way that's scalable, it's decentralized, and async? This was the thing. Limitation of previous solutions. So first off, you have like centralized solution, right? Completely off chain. And then you have like trust problems. You have like guarantees over like data integrity. You might end up with the data that's not there. You might not end up with any data because there is no guarantee over data availability and all of those problems. So definitely that was not a solution for us. Then we start looking at just like off-chain data, but with on-chain liveness guarantee. This is like very similar to like IPFS or other platform that basically guarantee that like the data is gonna be accessible, but it's gonna off-chain. But the problem is just like also usually it doesn't support like privacy of the data, so private data is not very clear how it's gonna be, and it's not gonna be programmable because the data that's somewhere and at most we consider that this problem that we want to solve is like a building block for a lot of like more complex logic applications that they need some sort of atomic transactions while exchanging data. So we want that programmability to exist there. And then we had the private, completely on-chain data, like fully homomorphic encryptions, like all of those approaches there. Sadly, still not very scalable to solve a lot of problems. So we realized, okay, let's see if we can design something in between that can solve our problem and can solve, like, satisfy all of the requirements that we have. So this is where, like, we first published our CDR technical paper somewhere last year, and the implementation recently released on Story Testnet, and that's exactly what I'm going to talk about. So what is CDR protocol? So CDR protocol is a natively supported protocol by Story validators. So it's a built-in protocol within Story. It allows you or anyone or any agent or anyone with like some sort of private data to secure and store private data by defining a dynamic on-chain access control logic. So I can upload the data in a secure way. No one has access to this. It's gonna be there. I can leave after that. It's async. And then I will put the conditions, dynamic conditions, that how one can access this data and like read or write or do anything with this. And this dynamic is just like defined as like smart contracts and is like accessible through like typical transactions and interactions with the chain, which means that you basically use this as a building block to just combine it with any other logics that you have on chain without the revealing the data. Data is going to be safe. Even the validators won't see the data at all. So you have a very high level of privacy, but at the same time, you can define the rules that should be enforced for access, and you can leave, right? You can do this, and you don't have to come back or do synchronized operations with the chain. So, and then we have a notion of vault, which is like that space that I was talking. It has a unique ID, it's identifiable, and it has some read-write access and terms and conditions that it was set at the allocation time. So you can say this function method on the smart contract will define like who can access this vault, or who can write these vaults, who can read from these vaults, and like all other different conditions that I will talk about. But like this is from like the protocol perspective, but if you change the view and look at from the object space, or like what this can do, it basically can let you have like on-chain objects. Like you can think of it like where NFTs was saying, like where like any struct or anything that you have on chain to even hold some sort of private data, which was locked before, right? Anything on chain was like publicly. Like if there's a struct, every data is publicly. But you can think of it, even you can move to a side that like one object that you have on chain can have like a private storage of the data, and then can define like who can access and like how is accessed and how it's gonna work. And the user flow, as I mentioned, is like very simple. Like someone can allocate a vault, these secure things, define like what is the read condition, write condition, and these definitions can be dynamic, as I mentioned. It can be like just referencing a function call, and that function called, like, it can be updated, it can be upgraded, it can be any dynamic logics that is needed to change over time. And the data provider, like the data providers, like can with the write access can write and leave, and the data reader with the read access can access it anytime in the future. So there is no source of like synchronized operations, or no need for these parties to coordinate in other level or another space or another where to just create keys or anything like that. It's just as simple as this. But what's under the hood? So the CDR protocol operates through a collection of software binaries that we call it kernels. And each kernel is provided by a single validator. So on a story. So each kernel, this piece of software, is running inside a trusted execution environment. So trusted execution environment is like a secure or hardware isolated area with hardware guarantees that like anything in that space is guaranteed to remain confidential and secure. And even like if the hardware is compromised, or if there are like someone like anyone access to those machines, they cannot actually like break this and like remove anything from this confidential space in theory. So, and then like we have these kernels, which is like all running their own, like all they're running in inside one of the TEs provided by validators. And at the same time, we don't want to rely on a single TE for the security. So we have like a collection of these kernels collaborating to secure the network. So in order for them to collaborate and synchronize and facilitate, like do the communications in a way that is safe and secure, we have a smart contract or a core contract in the center and a story that facilitates like registrations, communications of these kernels, and make sure they agree on something. So what do we do with these kernels? So these kernels in collaboration, they basically do two operations, group of operations is better. The first one is distributed key generation. So they do a DKG together in different rounds. So they have a notion of epochs, from epoch to epoch. They do the DKG, they generate the key, or do the resharing, or they do some operations to make sure the network has a public key that is known by anyone and is used for securing the data. And then the private key is distributed between many kernels. It's not even accessible by validators. It's just like lives inside the kernels and exists there. And the second one is like these kernels will, using these secret keys, they will perform something called threshold decryption, more specifically TDH2 protocol, which basically the core contract, whenever saying like, oh, decrypt this data for this user, they will participate and then decrypt the data for the final user without them knowing anything about the data. So they follow the steps, and their final assembly is on the user side. So no information is leaked to the validators or the kernels. So they will only participate to do this. Why we are doing it this? Because the safety of like this protocol is not just like based on one T. Basically, you need to break if you want, because there are some possible like very expensive and very recursive attacks on the T environments, like Intel XGX or TDX or other variations. But it's very like you require like root access, you require like basically hardware level access to do such. Like there are like very expensive and very hard attacks to be done by these things. But at the same time, we don't want to rely on that. So, which basically you have to compromise majority of the validators and break into their TEs to be able to break the CDR protocol, which is way higher, way harder than just like breaking into all the validators. So we wanted the security to be as maximum as possible, because we don't want like any applications that is using CDR has to have extra assumptions about the safety or anything. You can read more about the safety of the system and the protocols in our technical paper. It's very interesting. Like I will talk more about it in the future, but this is just like high level to see like what is happening under the hood. But what makes CDR a powerful infra protocol? As I mentioned, like we designed CDR initially for that problem, but later on we decided to just like give it maximum flexibility and scale, because we want to make sure that we can build as many applications, because we assume that like the private data on internet to be able to exchange on it or doing these things is broken. So we want to fix it as a bigger problem. So there are a couple of things that I pointed here to like show what kind of decisions we had on the design. For example, the interface, we separated, like there are this thing called between allocate, who allocates, who writes, who reads. So we separated all of these things because we assume there are sub-applications someone allocate. There would be maybe multiple writers, or temporary writers, or like some condition that someone can write. There would be some conditions that someone can read. There would be some conditions that like you need to adjust these as needed, right? So we keep that part like very flexible. We also let these conditions, for example, at the allocation time, the allocator to pass some information that is going to be fixed for and then later on used for subsequent write and read operations. I don't get into the details right now for this, but you can think of it like this. It was a very important piece because then it gives the ability for other smart contracts to wrap around CDR as an infrastructure later. Definitely when you start developing, you will understand what does this mean. The other thing that we were really intentional was like we didn't want the CDR to be like have like a very fixed read and write conditions that I mentioned. So that's the reason we completely changed it to make sure that it's just referencing other methods on other contracts, or like the simple case would be an address, but like the other contracts that can dynamically change the who can read, who can write, and do all of those things. There are some examples in this talk that I will get into, like how this is useful, right? Another thing was like we assumed that the data can be any size and any format, so we didn't want the protocol to limit that. So we have like the options to encrypt it. Like if you have, let's assume I have gigabytes of the private data that I want to do the CD, like put it in CDR. We cannot put like a gigabytes of data on chain for these things. So we like automatically in the SDK, we support the options for you to just encrypt this huge data, put it in any data availability platform that you like, anything that guarantees that the availability or the data exists. And then the key used for this encryption can actually be the one that is included in the CDR and transferred. So the space for the CDR vaults is actually considered like a wide range of like keys that can fit in. So you can actually grow any data size, technically any data format and anything in this combination. So it was also intentional to do this. And very last one, which I am the most excited about, is we also think that because of this dynamic read-write condition, one of the most interesting group of application that you can see, and I will talk more about, is like basically you can say like I will set the read condition to be the data to be only readable by a trusted execution environment that no one has access and is loaded very specific binary, and only the output is exposed to anyone else at the end. In other words, you can actually design applications that you can only share an output of an operations over the private data to someone without revealing that data to that person. So you have the options to just even go like one step further. Let's assume I have a database of a lot of information, and then I don't want to just like exchange it for like for some terms and conditions for some payments, but I want to give the ability to people to just like query if they exist in this database or not, and get the results, right? So there's like another level of like abstraction over the data, or like limiting, putting like this very specific views over the data that you can use, that I'm the most excited. But I will talk about all of these things into examples. So let's go over to some use case examples, so I can talk more about the technical sides and also like maybe inspire you. It's very similar to what Jacob was sharing, was like I will just capture from like how you look at this as a primitive to build your own applications. So private data storage, let's consider a simple basic case. Is just assume that there are like not that many parties that they want to do many exchanges, but there is a place that I want to store things and put some conditions over the access. It's just more like concentrating instead of just like parties interacting or many parties, or like very like terms and conditions, or like something like this, just like more like conditions that you can set on this thing. The basic condition, we did some optimization for CDRs. The basic condition is like if you set any non-smart contract address for read and write conditions, you don't need an extra smart contract to just define the rules and conditions. It will automatically consider this is the data reader, this is the data writer. So it's basically you have a private data storage between two addresses that can do this. This is the very basic case of example that one can build. The interesting part is like now you consider this basic case, you can actually make it more advanced. So what if I want to upload the data? It's like a company's data or some sort of data, but I need multi-sig for approval of a read. So let's like 4 of us upload some information, and then we agree that only if all of us signs, we can read that private data. One example, right? Read conditions require some multi-sig. Or what if it's like a time window access? So between these time, people can read it. Or what is just like conditional scroll? If I don't pay a loan on chain, I distance this data is revealed. Or many of these things, and then my favorite is like a dead man switch, is like if I don't interact with the chain for more than a year and there's no news from these things, well, I want my key to be transferred to a specific person or accessible by a specific person. Like these are like different things that you can see, like the read conditions, like different read conditions can be very powerful in types of application you can do. Like the dead man switch, like wallet recovery is the example, or like many other things that I don't have. So this is more like looking to some applications from the lens of like read access effectiveness. The other one that I talk is just decentralized data marketplace. This is where we start. Just like assume that CDR is the building block for atomic exchange of private data between two parties. So you have one party just provide the data. It can set terms and conditions and like proof of authenticity and extra. And someone else wants to pay and get access to this. The thing is, data provider uploads, leave. Data buyers, or like many of them, will come at some point. Anyone who pay, they can get access to the data. It's just more on the like parties that they can interact and transact. And this is an atomic, can be part of any other logic. It can be part of the marketplace, the smart contract can be part of like any bigger logic that can connect these things. And then the exchange of data, this atomic part, will be based on the CDR. And then we like some of the decisions I mentioned, like how we consider the read conditions to be like smart contract calls or all of those things, is for like functionality, for example, for data subscriptions. What if like I pay and then continuously get access to anything uploaded by the same data provider over time? So I don't need to continuously do this. I can like basically unlock different vaults based on the same condition. So you can see like different vaults sharing the same access control. So there are like very interesting things that you can build on top of this. So you can build data subscription, you can build any logic of complex logic between two parties or multiple parties that wants to exchange some data, and they want to have some atomic way of doing this. So it's just like if it goes through and if the payment is done, it's atomically exchanged. It's not the case that like, oh, what if the payment goes through, the data is not exchanged, or data exchange, the payment fails? Like you don't have those cases. The other group of things that I will talk is just like confidential query marketplace. This is back to the slides I was talking about. The power of this protocol is just what if you can combine CDR with verifiable confidential computational engine. Very big name. I put it this. You can ignore it. It's just basically any TE that provides the privacy over the data or like any temporary space. It's very common these days to use the TE and the zero knowledge to just create an execution environment that is guaranteed that maintains the privacy and is guaranteed to run a very specific binary with very specific operations with proof if they did this with the ZK proofs or other things. And these things exist. These components exist in many chains. This exist in many places, and it's really easy to build one these days. And then you basically combine this, which is like you have like a proof that this environment exists, and this is the key inside this environment, and all of those things. So you can combine this with a read access or write access condition, which means that this is the part that you can actually say like, oh, my data is not never readable by a user. It's only passed through this box that will accept the input, do something, and then expose the output. The very specific example we have here is like basically a fraud database. So I have like a repository of like addresses that did fraud, but I don't want to reveal them. And then I will only allow people to query if like a specific address exists or not, or their address exists or not. So I can limit the type of operations or type of computations over the data here. Another example you can think here is like, oh, I have an AI model that can generate output, but I don't want to share the models and weights with everyone, even if they pay. I only let them use. At the same time, on the other side, the user doesn't want to share their input with anyone out there. They want to just use the model, but they don't want to just provide their data as a training for the future or anything like this. So technically, two parties can collaborate in this verifiable and confidential space using the read and write conditions from both type of the data to be only enforced that this is the only spaces the data will be unlocked. So this is very interesting, because then it can unlock the very last one that I talk is just like multiple parties confidentially data collaboration, which is the ultimate assumption that like you have many parties, they want to do some operations. It has many applications. The simple case that I put in here is like you have multiple agents, they have their own private data, they have their own reasoning, they have their own business. You can build like basically an economy of these agents collaborate and interact and then exchange the data. Data can be an output of processing, it can be an output like of something else, and then they basically can collaborate and exchange value and data and everything else atomically. So these were just like the possibilities, and like I just want to show that like the design was towards just like making sure this is like flexible enough to support many applications, not just like a simple data marketplace or anything like this. And this was basically for inspiration. I'm assuming there are many things that interesting things can be built on top of CDR. It can be the medical space, it can be the agentic space, it can be financial space, it can be many different domains that an exchange of data atomically and asyncly, it can definitely help. And I'm excited to see what you guys are going to build on top of the CDR. And then, as I mentioned, we are around. If you have any questions, concerns, feedbacks, please do. Thank you.
Woohoo! Woo! Thank you, Ramtin, so much for hosting that workshop. We had a bunch of questions in the chat. It was great to answer those. Does anyone have any remaining questions quickly while we have Ramtin here? If you do, go ahead and put them in the chat. Yeah, I'm gonna wrap things up here because I don't want to keep you guys for too long. Let me go ahead and share my screen again so you can see the schedule. So we have, remember, for those of you that want a builder workshop in Korean language, you can tune in tomorrow at 7 a.m. Eastern time or 8 p.m. Korea Standard Time. That's going to be, again, in native Korean language. And then at 11 a.m. Eastern time tomorrow, I'm going to give a builder workshop in English on how to, build with CDR and use the SDK. So we have a few questions. Do we need to start from scratch? No, you do not need to start from scratch. You can definitely bring an existing project in and add CDR to it. So yes, you can do that. We have a couple claps from the chat. Awesome. Thanks everyone for the claps. So yeah, remember to tune in tomorrow. You can tune in at the same exact link that you're watching this at. It's going to be on our Story Engineering Twitter, or you can go to this live page. And the only other thing I want to say is make sure to join our Discord at the bottom here. Join the Discord because you can ask any questions you have there. Also, if you need test IP tokens to develop with, just let us know in the chat. We've had a bunch of people already ask for some, and we're sending them out as soon as we get the request. So join the Discord. Let me know what you're building. I would love to help you out and help refine your idea. And again, if you want feedback before submission, I'm the best person to go to. So we have workshops tomorrow. Join the Discord, and best of luck, everyone, in building your projects. I'm really looking forward to judging all of them, and we're super excited to introduce this new awesome protocol feature to all of you. So thanks for tuning in, and we'll see you tomorrow during the workshops, or not, right? They're not mandatory. They're just there if you want them. So Thanks so much, everybody.
Thanks,
Waving
everyone.
waving to the camera here. We'll see you tomorrow. Bye-bye.
Bye.